All right, so these are informal rules. They're not the formal ones, but I find these probably easier to remember and easier to use, okay? I sometimes call them the thou shalt nots. So zeros are not significant if they're supposed to be rounded off. So if we already talked about rules for rounding off in multiplication, division, and then a separate set of rules for addition and subtraction, if we've already talked about digits that have to be rounded off, zeros aren't significant if they're supposed to be rounded off, okay? All right, leading zeros, those on the left side of a number, okay? Since we read from left to right, the ones in the front are the leading ones to the left. Those are insignificant. And the zeros on the right are insignificant, but only if there's no decimal. Okay? So let's talk about some examples here, though, okay? Let's see. If I'm adding up some numbers, let's do 12.624 grams of something and 1.4962 grams of something. Let's just say we're going to be doing gold. Okay? So we add those together. We got a 2 here, a 10 here. That makes that a 12. So that's 11, then 14. Did I do it right? Okay, so I have one empty slot over here on the right. And so that means that 2 has to be rounded off. So 14.120 grams of AU. That zero is significant. Oh, I'm sorry. That zero is significant. Okay? We didn't round it off. Got it? All right. Now, if I do 3.47 and 1.583 and 0.117, and then we'll make this milliliters of mercury. Okay, we'll add all those up, and we get a 10 here. That becomes a 16. That becomes an 11, 4 and 5, I believe, millimeters of mercury. Okay, so now we got an empty slot here. All right, so the rules say this digit has to be rounded off. So no matter whether it fits any other rule, if it has to be rounded off, it's not significant. So that's applying. All this is applying to rule number 1 up here. Okay, does that make sense to you? Just giving you examples for zeros that have to be rounded off or not rounded off from the other rules. 5.16 milliliters of mercury. Okay? You understand what I'm saying? Not hearing anybody. I guess you're just writing notes because you can't think and write at the same time?
Right. You're going to
Well, what are you going to do in college? Where the professors are just going to keep right on talking whether you're keeping up with them or not. And you really think you're going to have time to listen to the recordings? Huh? You know, the rule of thumb is if you're going to be in college, you can expect to do, and this is without listening to recordings, you can expect to do 3 hours of work outside of class for every 1 hour in class. Okay? That's homework, research, various things like that. Add it all up. And if you're going to be successful in college, you can expect to do 3 hours of work outside of class for every 1 hour in class. Okay? So, yeah, I guess most professors probably wouldn't mind. Some would. Some would say, no, you can't record. And in college, the professors have a lot more power in terms of setting rules for their class than I do as a high school teacher. So if they say no, it's no. There's no appeal. And they have a right to kick you out. If you violate their rules, you're gone. Okay?
Free money.
Huh?
Free money.
Free money? Oh, for the school? Yeah, well, that's true. Because if they kick you out for violating rules, then you can't get a refund. You know, that depends. The rules, schools always have rules about when you can withdraw and still get your money back. They usually do that, but at a certain point in the semester, you know, you can't get them back. Okay. Now, you can go back and ask the professor to let you back in. You know, they might do it, they might not, depending on the severity of the situation. And you can try appealing, but typically the professor's, you know, in charge. Okay, I know professors that, you know how students tend to chat in class and not pay attention? I know professors that have kicked people out of class for that. Just kick them out. Don't come back until you can be quiet. Pay attention and participate, you know? All right.
So how much work did you say that you have per hour?
The rule that I've heard is that, and I followed this rule when I was in college, okay? When I added it up, yeah, pretty much, and it doesn't apply to every single class, but if you average all the classes out, I did about 3 hours of work outside of class for every hour in class. Reading, studying, doing homework, doing research work, okay?
So when you party?
I was thinking that.
Well, let's try to remember partying is gravy. It's not the meat and potatoes of going to college. Okay? All right. So I could show you also the same sort of thing for multiplication and division here. I'm just giving you an example for addition. Okay? That the zeros that have to be rounded off okay, you can't apply some other significant zero rule and say, well, that's significant, I don't round it off. No. If you're doing multiplication division or if you're doing addition and subtraction, if the rules say you round it off, it's rounded off as not significant. That makes sense? Okay. So I'm trying to avoid some confusion. All right, so here's an example, or maybe two, for number 2 here. Let's say we've got this number. All right. According to rule number 2, leading zeros, those to the left are not significant. How many significant digits in this number then? 1, 2, 3. The zeros are not significant because they're to the left. There's how many significant zeros? I mean, how many significant digits? 3 significant digits, okay? Now I'm going to use the shorthand SF. SF in plural is SFS for significant figures. Sometimes you use the word significant digits, sometimes significant figures. It kind of means the same thing, okay? And if I have how many significant digits in this number? Just 2, right? All right, does that make sense? All right, so here's the example number for number 3. Go it up a little bit. All right. How many significant digits in this number?
4.
Just 2. Okay, and here's why. If there's no decimal, and there's no decimal in this number, then the trailing zeros are not significant. Okay? Does that make sense? Got that? All right. But if I do this, now there's a decimal place. So we have no rule for insignificant digits here at all. How many significant digits in this number?
3.
4. Both these zeros are significant because there is a decimal place, trailing zeros are significant. That makes sense? Okay, so this has 2 significant figures and this one has 4 significant figures. That make sense? All right then, everybody got that written down? Okay, so let's go and look at the formal rules then, okay? I find these informal ones easier to remember and use. You might like the formal rules, okay? So significant zeros here. So here's the formal rules. These are the thou shall. Okay. All right. Now there's two rules for significant zeros. One of the rules has two parts. One of the rules has one part. Okay. So I'm going to start with what I call the one-part rule. Okay. In the one-part rule, any zero between two significant digits is significant. It'd probably be easier to remember that if I said any zero is significant if it's between two significant digits. It's just an easier way to follow what the sentence means. Does that make sense? If you'd rather write it that way, any zero is significant if it's between two significant digits. All right? Clear enough to you? All right. And then we've got that two-part rule. So the second rule is I call it the two-part rule. So in the two-part rule, you have to meet both conditions for it to be significant. A zero has to meet both conditions to be significant. Any zero is significant that should be if it both. Okay. And that's going to be, the first part is, if it both follows a decimal place, or decimal, and then and 2, it follows a non-zero digit. So there's kind of an aside to this that may help you understand that you need to know. Any non-zero digit, that you don't have to round off is always significant. Okay, so that's why we only have significant digit rules for zeros, because the non-zero digits don't really apply to most of what we're trying to figure out. Okay? Alright, so let's do an example for the number one for the one-part rule here. Okay, example for number one. 12.0700. Let's say this is marbles. Okay.